Hi, I'm Tom Marks. Welcome to another PlayStation 2 programming livestream. Today we're doing more work with my level editor workflow. We're gonna try and get some better flow between LDTK and the PlayStation 2, and hopefully be able to place some decorations in the level. Last stream I did this. If I can get a pen going, I did this. This is done. We're checking it off. Areas to trigger events and levels. Let me do that. Not in the background. So we now have regions. Let me show you in LDTK what this looks like. Okay. I pretty much got it done last stream. Good morning, Prof Elements. Hello, welcome. Thank you everyone who's stopping in already. Great to see some faces in chat. So we can put these trigger zones down, and we're saying it's a load level zone, and it loads the level entry 2, which is over here. And then entry 2 has a couple of trigger zones as well, one that loads this zone back in, and one that loads this little level here back in. My tile set's really ugly, but other than that, I think we're doing pretty well. And last stream, I left it almost done. And off camera, I just thought I would go in and fix it. So let's run PS2. Let's show it running on a real PlayStation 2, and I'll talk about what's actually happening while we do it. Cool, so this is the game. We've got our little character moving around, it's good. Let me actually swap my screen so that I'm not seeing that on a 1.5-second delay. Not that there's a lot of platforming to do yet, but we hit this zone and it's going to load in a level off to the right. Now, we haven't gone async yet, so we still freeze the game while that happens, but that's okay, we can deal with that. We come into this little area here. This loading zone will load the level chunk on the left if it's not already loaded, but we can see up in the top left, my ugly grass tiles are still there. It's still loaded. When we hit this zone down here, it's going to load the next area down to the left. And actually, because I haven't done this very well, if you head back up to the left, you can see that the tiles we walked in on have disappeared up in the top left of the screen because they've been deloaded. Cool. I made a couple of other little improvements as well, actually. Areas that are totally outside of the camera zone no longer get rendered, which is good. And then, yeah, there's this little platform down here. So this is all just testing stuff out, right? These are just random little spaces you can move around in. But if we navigate back up to the top, we're going to have to go through another freeze the world loading zone. Not this one. These little red zones are the loading zones. I'm drawing them at the moment for debug purposes. We hit this one up here. And despite freezing, we get up to the top, and now this platform's reappeared. We can get down and see everything nicely. So this works. We can load these in, these triggers work and do things, and we can stream in levels from LDTK. So let's just remind everyone, this is exactly what we saw in LDTK. Really, really important. Really, really cool. Prof Elements asks how we would do async stuff. Does the PS2 have threading? The PS2 does have threading. It's a CPU, it has threads. It has a little kernel, a BIOS kernel that manages it. Every time I've tried to do threading on the PS2, the threads just hang forever, and that's not good. So that'll be a stream of trying to work that out at some point. Not today. For now, we're just going to continue to freeze, and we're going to make sure that the loading code works properly. I think that's more important, right? Make sure the loading code is absolutely bulletproof, then async it. And then if things go wrong, we know the problem's just with the async part, not with the actual level loader code. I think that's what a clever person would do. Cooperative threading. If a thread doesn't use it, runs forever. Yeah, okay. That makes sense. Make it work, then make it interesting. Exactly. The pause isn't so long that I'm concerned about it. Cool. So one thing I really want to be able to do is put something down, put some kind of decoration down that isn't a tile from my tile set, right? That would be a great way to have a bit more visual variety. And I'm not sure how we do this in LDTK. I haven't really worked this out yet. I think maybe, like, we're probably going to have to put some kind of entity down. And let's just experiment a little bit. We might have to do something a little bit jank. Let's just make an entity called decoration. And we can set a visual. We can add a tile set and set a visual, but I kind of want a different visual for each thing. So we'll make it resizable in width and height. We'll make it yellow, maybe something like that. And let's also open a sprite and just draw something that we're gonna put in here. Let's make it maybe 100 by 80. Actually, no, let's not make it 100 by 80. Let's make it 64 by 64 because that's a sensible PlayStation 2 size. And let's just draw something here that we can put. What would be a good decoration? Let's maybe draw a little corner thing. Is that this color? I think that's this color. Now let's look, I'm just going to put like a circle. I'm just going to do a really crummy little circle looking thing. And I'm going to put a cross on it because then it has a little bit more intrigue. It looks a little bit like an Xbox logo. Okay, so we're going to export this. We're going to put it in my assets. We're going to call this test deco dot p. We're going to do it as a PNG. Then we're also going to export it a second time as a TGA. Annoyingly, LDTK does not support TGA files, and my engine doesn't support PNGs, so we're going to export both. Bits per pixel 32, don't compress. Perfect, that's what we want. Okay, so if we add a tile set, we can add this as a tile set, right? Tiles layout, 64. So this whole thing is one tile. Grid size is larger than the previous one. Okay, good. We don't want tiles. This does not have tiles in it. This is just one image. We're kind of hacking the system here. So decoration, what happens if I put a decoration down, right? What happens if I put one down here? We can't really change that, can we? So maybe we need one entity type per decoration, and that would be workable, but it wouldn't be great. So we could do this. Fit inside bounds. Yeah, cool. And we can scale it, and that scales as you would expect it to. So maybe we really do just need one decoration for each thing. We'll call it decoration orb test. And we'll give it a tag, and that tag will be deco. So an entity with the tag deco is going to be a decoration. They're going to be handled differently to other entities. Cool. And we'll just put this like here, I guess, where we can see it nice and obviously. Cool. Okay, so let's have a look at what that looks like in the actual file. Actually, we've got a bunch of random crap I should probably commit first. Oh dear, I forgot I'd done so much stuff off camera. This is this whole thing. Let's just quickly compile LDTK. Compile trigger zones from LDTK. Then we just maybe want to add. Yeah, I got a little bit. This is one of those bad commits, but that's okay, that happens. Sometimes you have a bad commit. Don't draw levels. Cool, okay, there we go. Perfect. No one ever needs to know. Let's add this missing file as well. Cool. You'll approve the PR. Thank you. Thank you. I've got an emote for this. I've got an emote for this very situation. Nice. Okay, so now let's open up the LDTK file and have a look at what's going on in there. Let's make sure I saved. Cool, so tags deco. This is exactly what we want. So we have an entity. This is an entity definition, I think. Test deco. Now, so this is an instance, is it? Maybe it isn't. Tags deco. Collision. Hold on, levels. This is what we're going to find. This is a level. These are the layers. This is an entity layer. These are the entities. There's that trigger zone. That's good. There's that player start. That's also good. Decoration on test. It has the tag here. So we don't need to resolve the actual definition. That's good. So I was concerned that we would have to look at the identifier for the entity and then look up the identifier in the entity definitions. It doesn't even matter. It doesn't even matter. We do need to look up a tile set by ID to work out exactly what we're drawing. So let's think about what a decoration is really quickly. But this is good, this is good. It's good to know that this data is here. So let's think let's define the definition of a decoration. And this is going to be another type of thing. They're not going to be a normal entity. They're represented by an LDTK entity, but we have a couple of extra concepts that we can't, we're using LDTK entities to represent a couple of different things. So we're going to have level decoration def. So this is going to have like an area, a local offset. This represents its position within. Oops, my water bottle is dangerously just off camera, right in flailing arm range. We're going to have a local offset that represents its offset within the level. We're going to have bounds, which represents its size. We're going to have a couple of other things. We're going to have a uint32t, which is going to be an asset ref, an asset index. Let's call it asset ref. I think that's what I've called it up here, right? Which tile map, which texture does this refer to? And this should be a get uint32. And we don't need a map file offset here, do we? We need uint. Let's make it uint32t's. This is going to be the UVs. And there's going to be 4 of them, right? What are the coordinates within the texture that... and actually, this can probably be a uint16t because they're going to be in a slightly smaller range. What are the coordinates within the image, like UV, UV, the top left and bottom right corners that we're going to reference as a texture? I guess we could make these floats as well, but that's less fun. Cool. Okay. So I've got a decoration. We also need to think about what this is going to look like when it's loaded. Because this is going to have some loaded structure as well. Will be something like struct, loaded deco. It's going to have a lot of this information. It's going to have... But I think here maybe we're going to do a world position. It's going to have bounds. It's going to have an asset that it references still. I guess we might make this a size t and call it a texture index. And we'll still have... Except we'll convert the UVs to floats. Maybe? Potentially? Let's keep them as whole numbers and then we'll do the division every time we draw it. I think that's okay. Okay, that sounds good. That sounds reasonable. So we'd need to add that here. We'd need to say struct. Bobbius, good morning. How you going? Let's just call this decos. Just call it decos. We'll have, n of these. So let's add the extra structure here. So if we have level decorations, we're going to need a decoration. Let's call it deco def count decorations. Things that we're drawing. Things that are not tiles that we're drawing. Cool. And so we read this number of these things, then we loop over them, and we hook it all up together, right? There's not actually that much that has to happen. I guess one thing that would be good to know would be to think about what drawing is going to look like with this. What is drawing going to look like in this world? Because after we've drawn the tile map, oh yeah, we do these, let's comment this out for now. I think we're happy with this. Draw trigger areas. It would be good to have some kind of flag we could control, like open a menu and select if we're drawing these areas or not, but for now let's just comment them out. Cool. So I guess after we do the tile map, let's go for int I equals 0, I less than loaded deco count I plus plus. Cool, we need to add that because I haven't done it. We're going to have a deco count. This is still valid, I guess. Let's put mark Z there, then we can jump around really easily. Good. Okay, so loaded deco, world offset, bounds, texture index, UVs. So what we're ultimately calling is going to be draw put tile? I guess put tile. Now I guess we need put sprite, where we take a texture, we take an x, a y, a width, and a height, and then we also take a float, u naught float, v naught float, u1 float, v1, right? The uv coordinates within that sprite. I could just use an if-def. I could. That's true. But if-defs I find somehow even more clunky than code comment blocks. Oh, I guess you can do like if0. Yeah, this is true. This might be better style to go like. But yeah, you could also go if-def debug draw areas. It'd be better runtime toggle to draw trigger areas. It'd be good to have in general, just like a runtime toggle for debug drawing. So every level could draw its stuff, entities could draw their collision stuff, whatever they needed. But yeah, for now, I guess an if-def is okay too. I'm likely to just delete this, or like change it to an if and def if I really want to compile it in, rather than adding a -d flag, but yeah, you're right. The problem with this, by the way, is that unless you do a clean rebuild, right? If you're doing an incremental build, if you change a -d flag, you need to rebuild the source unit. What is it? The compilation unit that this if-def is in. Otherwise, it doesn't re-trigger a rebuild. So sometimes you get stuck. You think it's good for things when you're not incrementally building. Like when you're in this stage of development, it kind of catches me out sometimes, just from experience. Cool. So we've added a new function here called put sprite, and that's exactly what we're going to do. Put sprite. So we need to work out. Let's say. Let's just calculate these the dumb way for now. So the first UV coordinate is going to be, well, actually no. Let's get a reference to this too. Struct loaded deco d. This is going to be loaded decos I. A. Oh, I put my A marker back there. There we go. Cool. Caching shenanigans. Exactly. Caching shenanigans, off by 1 errors. What was the other thing? There were a couple of things we were saying in the PCSX2 Discord the other day. Classic errors. So I've called these UVs, and they're not really UVs. These are like, let's call it maybe texture. I guess they're ST. Is that what they call it, right? STs, yeah. Naming convention? Okay. I'm pretty sure pixels, corner point, surface, coordinate space, yeah. That's the polygon, texture, coordinates. It's weird. There's lots of difference of opinion in this. I'm pretty sure on PS2 land, these are named different. So let's maybe call it texture region. And then we don't have to worry about this confusion. So we'll say D texture region. So the top left corner, and we have to divide it by float. Let's turn everything into a float, because this makes me nervous otherwise. Integer division in C is really scary. It's really easy to end up with an integer when you don't want one. We want this as a percentage of the overall texture's width. There's a smarter way to do this in the PS2, but we're going to do it this way just to keep everything uniform, even though it's a bit more CPU thrashing. We're going to divide by the... Oh, well, we need to get the texture as well. That's the other important thing. So an invalid texture, I think we use... Oh, I just put my A mark back here. That's so annoying. They're like right next to each other. Okay, I think I have uint32 max. Yes, so that's my invalid asset ref. So after we do this, if d asset ref, I think I called it texture index. Problem, multiple names to name things. Solution, use your own names instead. Literally, right? Sometimes naming conventions are confusing, and sometimes you have to step outside of the conventions to avoid further confusion. Sometimes some names are so corrupted by years of just conflicting bullshit, you just have to step outside and do your own thing. That's fine. That's okay. Okay, so texture index is this. Then we just continue. There's no work to do. There is no texture to draw here, except we should maybe this is an error. Invalid texture, because we just shouldn't load this thing, right? If it references an invalid texture, it shouldn't even be in this list. We shouldn't even be considering it. We should have already flagged this and either caused an error or just accepted that we're not trying to draw this thing. We've just given up. Invalid texture. Deco. Draw deco. Invalid texture. D. Like explicitly invalid texture. But we're going to continue anyway. We're not going to let that stop the world. If the texture index is greater than or equal to loaded texture count, asset count, texture count, then log error draw deco I. Oh, and it's %d, not %i. What am I doing? So this is going to be I. I mixed up my I and my d. Very easy problem to have. This is texture index out of loaded texture count. And I guess we continue here as well. Maybe that's not a terminal error. I don't know. It's a pretty bad error, but it's not terminal. Okay. Now we can keep going. So now we can grab struct ee texture text, and this is loaded textures d texture index. This is the kind of scary point where we're putting together references to things, and that's where it's really easy to blow things up and cause seg faults. Text width. I'm pretty sure text has width. It does. So we're going to do the same thing for v. This is going to be, it's divided by height. And this is just going to be the other two coordinates, 2 and 3. Excellent. And I think that's pretty good. We're going to have to draw up. No, we do that at the start of the frame. So one of our invariants is that all of the textures within a level chunk have to fit in VRAM at the same time. If they don't fit, then we've got a problem. They all have to get allocated. So they all get allocated up front when we create them. And this is one of the reasons that we chunk levels overall, is that we want levels to be self-contained like that. And if we need more stuff in VRAM, we have to chunk it off into another level. That's the goal. That's the goal. It'd be good to have some kind of metric about how much of VRAM a level is currently using, because it shouldn't change after we initialize it. We should load once, and then that should be it. One of the reasons we don't have a player sprite yet is that we're also going to need things that are in kind of global VRAM, but I haven't considered that yet. I haven't done that yet. Cool, so we're just going to call this new draw function that I defined, put sprite. This is going to take our texture. This is going to take our d world offset. Except we have to do this relative to a camera. So we have to do this. We have to do this. D. And actually, yeah, maybe it is better, because when I did areas, I just copied them because they're kind of small, and copying can be better, right? You do the memory, like they're small enough to probably fit into one memory unit, one, I don't know, cache line. So maybe it doesn't matter anyway. But anyway, worth thinking about. What did I call this field? I didn't call it position. I called it world offset. I probably should call it, I'm gonna rename it to position, because that's more consistent with what I've done elsewhere. Let's make it a float. Other things use float as, yeah, other things use float as positions. I think that's good. I think that's fine. Cool, camera position. So we're gonna use this AX, and we're going to call them AX and AY, even though that doesn't make much sense anymore. AX, AY has a width and a height. That's going to be bounds 0, D, bounds 1. And then we're going to do the U0, V0, U1, V1. Beautiful. We're going to do that for each thing. I'm going to say if that returned an error, then we want to log an error, draw deco D, put sprite. And I guess we don't quit out. I guess we don't do that, because that would be bad. We just power on through. We keep plugging on through. And again, maybe this should be like an if-def toggle where we're like, oh, some things are not severe enough to crash our program, but for testing purposes, we probably want them to. Maybe. So what if I make this now? What happens? Yells at me about a couple of things. We missed attrib. I don't know how that happens. Attribute. That was a real brain moment. T is undeclared, first use in this function. That's because it's D. Also, this should be texture index. I don't know how that happened. Apparently my brain is just, I'm having real brain issues today. That's okay. Some days are like that. Undefined reference to put sprite. That is the big thing. So we've done the arse end of this, if you will. We've done the end of this that actually draws stuff. What's missing is, so what we've done, so, oh my gosh, can I please not detach my windows in the GIMP? Okay, so we're gonna have, for one thing, we've got the LDTK file, right? This is like the golden file. Okay, this is LDTK. This has all the stuff in it. We unpack this into several other files called .ps2lvl, you know, something x.ps2lvl ... These all then get packed together into assets.wad. This is one super file. Assets.wad gets loaded. I'm going to change color for this. It gets loaded. Well, I guess this gets loaded via assets.wad. Let's follow this one level, which goes through here into our level loader. That's going to take all of the decorations. That's going to map from a deco def into a loaded deco. And then in our main loop, on draw level, this is going to go to the GS and get drawn. Right? This is our data flow for what we're doing right now. This is how it all goes. These are the steps. So this bit, we've just done this bit. That's good. That's done. Check. Yeah, an asset management pipeline. An asset management pipeline that works on the PlayStation 2. I've done a little experiment hot reloading things like while the game's running, and it bodes very, very well. So I might, if I get this working this stream, I'll probably do that next. So I'll get something running on the PlayStation 2, and then I'll press a button and reload the entire assets WAD, all the levels, all the textures, while the game's running. That's the goal. That's the ambition. That would be very, very cool. So move something in LDTK, hit save, run a makefile rule, hit a button on the controller, and on an actual PlayStation 2 it dynamically reloads. That would be sick. That would be really cool. That was always my goal. That's why I've built everything the way I've built it, and why I've built so much from the ground up, and hopefully it's going to pay off. I'm really close to 3D as well. I'm like this close to 3D, and tightening things up for this little 2D game, that's going to get me closer to 3D. Cool. So let's do this bit. Let's do this bit next, and then we'll do the glue in the middle last, because this is the most tedious and error-prone bit. So let's parse the entities, because we're already doing a little bit of this. Compile LDTK, right? We're already handling entities when we do area definitions. and this is part of object construction, right? For area and trigger areas. And we get this from the LDTK side. Okay, so this is good. So we've kind of baked one of my game concepts. Oops, I'm on the wrong scene. We've baked one of my game concepts into this LDTK script, and I think that's okay. The next thing we want to do is levels, entity decos. Well, maybe I'll say deco entities. Right, and this is going to be the same thing. So for every entity layer, because we could have multiple entity layers, for every entity, we're going to get it as an entity. And except now, instead of looking at the name, we're going to look at the tags. We're going to say if entity get tags, or let's say maybe contains tag, has tag deco. If it has this tag, then we're going to yield it. Otherwise, we do nothing. And then we just go through and fall through, and it's all good. It's all good. So, yield entity. So if has tag, that is something that we're missing. Let's go to our entity, and let's say... Now, I think lots of things actually have tags in LDTK. Game world. Tags. All of our entities do for sure. Entity instances. Just our entities. Okay. So let's just put this on entities. Let's say def has tags. Has tag. Self tag. And then we're just going to say return self dot dict tags. I'm pretty sure that's not what I wanted to do. I'm pretty sure Python foo bar contains foo is no. Oh, hold on, no, it's foo in. We want to say tag in this. Tags. Cool, because this is a list. Easy. Easy. So we can get, don't all of them have trigger? Why not use a tag instead of a name? Because, well, this is a good point. It's 50-50. The name of the entity is actually the name of the entity like class in LDTK, which is a bit confusing. You can't just give an instance of an entity a name, it's the whole entity class. So it seemed more useful to be more specific for now, but in the case of these decorations, like because this is an entity class, like every individual decoration is going to have its own entity class, which kind of stinks, but we'll survive. But you're right, I could do it that way. I've landed on this way for now, but I might change it to tag in the future. And I've tagged all of them with something. I think it's more likely that all of my trigger areas will have some kind of like collidable tag that other things might have as well. And that might have some extra meaning. And it might end up being a different system. I don't know. I think it's better to tag proactively because then I don't have to go back and do it later. That's the goal. But again, because they're entity classes, I can go and change the tags of the entire class, and then all of the instances will have different tags as I go. So LDTK is very flexible, I guess, is what I'm trying to say. Okay, so we can get all of the decorations. Now, one of the most important things here, we need to, has a width and a height and px. Get dimensions, get offset. So we have that, that's easy. Field instances. Wait, are these definitions or are these layer instances? No, this is okay, You can use, exactly, yeah, if I want them to have names, I can do that, but I don't have a need for that right now. But yeah, custom fields are kind of like instance-specific data. What this calls an identifier is actually an entire class identifier. It looks like a name, but it's not really what I would call a name if I was doing this. I would call it like class name or something similar. We need to resolve some data. We need to resolve tile. We need to resolve this. Yeah, it's not unique to each entity, exactly. Tileset UID. XYZ. So this is good. This is literally what we're going to put into those fields in here. This is the asset ref and this is this, but we need to resolve this asset into an actual asset name somehow. Now, Okay. We can do this. This is fine. This is fine. Tileset UID. Okay, so UID. So the tileset is going to have a UID, I imagine. Tileset UID. Okay, what's the name of this file again? Where tilesets? What's the name of this file? Test.deco.png. Test.deco.png. Okay, so where is this? This is tilesets, entities, defs. So level, no, this isn't even in a level. Defs, layers, entity. Okay, so this is in the top level thing. So in our, not even in our levels, this is, so this is here, defs. This is on the same, yeah, the same level as defs. Okay. So let's make a function. We'll call it get tileset by UID. And we'll do it this way. So self.dict defs tilesets. I keep pressing the wrong button, I'm really sorry. Tilesets for TS in this. If TS UID, we need to actually give it a UID as well, equals UID, return. We just want the name of it really. We'll say return TS rel path. Raise exception, no tile set with UID. And I didn't put an F, that's okay. Cool, beautiful. I think that works. So, that's okay, now, how do we actually... this, tile. So an entity might have a tile. So if an entity has a tile definition, we return it. We just return if tile none of the others actually have, oh no, they have it. V is self dict tile. If V is not none, return. Well, I guess we just return it, right? And if it's none, consume at your own peril. Consume at your own peril. If it's a decoration that doesn't have this, we're probably happy for some kind of runtime error because it means the person making this level's done the wrong thing. We can worry about nicer errors in the future. Compile LDTK. Okay, so for D in O dot. Now, what did I call this? Deco entities. Cool. Self decos and add decoration. Beautiful. And now we just need to serialize them. Yeah, sure, because we need to serialize them, but also, now this level doesn't know where it came from. So maybe levels need a backlink to the parent object just so that we could, just because we need to resolve these UIDs, because we can't do that for a level. Like, we don't have enough data just in that level to resolve a tileset UID. What's probably better would be to pass in some kind of map as well to the level, like a guide for resolving it. Maybe that's actually better. Def, like maybe what we actually need to do is for ts and self.dict defs tile sets. Well, maybe we just need to return this. Also, I can actually simplify this as well. That's really silly. I thought I was going to do more processing. Oh well, because I construct that into an object, I guess it's different. But I can map instead. Let's do it with a for. I don't like maps in Python. Let's do this. Let's make another object type. It can't hurt. LDTK entity layer. Okay, let's do it up here. Class LDTK tile set. Okay, and then the field is called UID, I'm pretty sure. Tileset's UID. We're going to do the same thing here with this rel path. Nice, and I think that's all we need. Everything else I'm pretty sure we can work out later. Nice. Now in the consumer, we can, from the world, we'll say tile sets is world.tilesets. Actually, no, let's make it a dict. Then we'll say for ts in world.tilesets, tilesets ts.get UID equals ts. So make a map so we can look them up by UID really easily. Do that pre-processing up front. And now we're going to pass in the thing that lets us resolve tile sets as well. Cool. Gets an extra thing. Level self.ts lookup ts. Right, we can look up a tile set by UID. Good. This is important. This is important. Now, when we serialize the decorations, we'll have to do that. Def serialize deco definitions. I don't actually think we need the data chunk for that. There's no data, there's no file offset, there's no lookup. What we do kind of need to know is which asset this corresponds to. But assets are just names. Assets are just names. So let's add a method to this. Let's say get asset index for a in self.assets. If a equals name, ia in enumerate, we want to get the index as well. Then return I. Otherwise, raise an exception that says asset not defined name. Beautiful. Okay, this is good. This is what we need to link it all together. Because UIDs in LDTK are different to the IDs that we use because we just use indexes because indexes are simple. And we're building the dumbest thing possible. That's always the goal. So we're going to do the same kind of thing for D in self.decos. This is going to be a much simpler one because we don't have to worry about this data chunk writing. We don't have any data that lives outside of the scope of this decoration. Decorations are very simple compared to the rest of our data. They don't resolve any data that lives later on in the file. Okay, so bs append struct.pack. What do we have here? how did I define this? So 2 signed integers, and then 3 unsigned integers, and then 4 unsigned half words. Okay, beautiful. What have we got here? What is a deco? A deco is an entity, so we want to say a dot d dot. Now this wasn't turned into an object. That's the only thing, right? Maybe we should do it. Deco dot from LDTK. Nah, screw it. This, because it's simpler, I think it's okay to use this directly. So we'll say l dot get offset, I think. God, it's hard remembering the names of your own functions, isn't it? Get offset. And this returns a tuple, so that's good. Then d.get dimensions. This star just means unpack it, right? This gives us an iterable thing. Put them in order as arguments to the function. Struct is such a nice library. I built a bunch of, when I was doing Kingdom Hearts stuff, I didn't really show it off, but my elf patcher was just written using Python struct. Like literally read an elf, and it did all kinds of complicated stuff. There's also a function, you can struct pack. You can also struct pack too. So if you have like a huge stream, a huge buffer with a bunch of stuff in it, you can pack and unpack to and from an offset, which is so nice. So if you've got a binary for a game that you're modifying, you can inject things at very specific points, and it's pretty fast. You can move a lot of data around pretty quickly, as long as you're not doing stupid stuff and thrashing the allocator. And unpack from and pack to, they're kind of like the keys to doing that. It's good. It's really good. Okay, so fmt.h. So we've done the bounds, the asset reference. Now, we should probably do that up here. Let's say texture name is self.ts lookup. In this lookup, we're gonna get by UID, right? So d dot actually let's say tile draw tile is d dot get tile UID. I think that's what we have. Game world deco. This deco tile set UID. Okay, so get the texture name from that, and then asset ref is self dot get asset index. Look up the texture name, and then use this asset ref, and then the last 4 things are the UVs. So that is tile X, tile Y, tile W, no, hold on, tile X plus tile W, and tile Y plus tile H. Cool. Which in this case is nothing, because X and Y is 0, but we don't know that in general. And I think that's it. And then we just have to return. And this is not the most efficient way to do this. This is definitely not the most efficient way to do this. Especially in this case, we could kind of pre-allocate the thing. There are all kinds of cleverer things we could do. But that's okay. We also need to work out how big this is, because we're going to have to say len self.decos times, right? This is our offset. This is where our data chunk starts after all our headers. But we have to work that out up front, I think. Oh yeah, we do, because we have to do we cross-reference. The header has to reference the data chunk, and we want to resolve these up front. We don't want to have a second pass to do that stuff. It gets messy. So deco def size. This was wrong last time. I think last time I had to put a +4 in here, and that was just because my area def size was 4 too short, which is, I mean, it's kind of good, right? The thing that's missing for me is an API where I can pass this string in and it tells me how big it is. That's the only thing I think is missing from the struct library. Maybe it exists and I'm just a big dummy and I haven't worked it out, but I don't think that, I haven't been able to find that exists in Python. If you know otherwise, please let me know. Struct's nice for writing interop with Blender and other binary formats. Yeah, that's cool. I never thought about the Blender APIs, but that definitely makes sense. More languages and similar libraries. So many serialization libraries go overboard. Yeah, literally. Like, it's easy to over-design. Python does the simplest thing, but also has enough nice magic in it, right? It uses its strengths as a dynamic language with how this function handles its arguments and how you can do kind of, you know, inline unpacks in the middle of an argument list. Oh, mwah, beautiful. Okay, so how big is this thing? It's 5 times 4, which is 20, plus 4 times 2, which is 8. It's 28. It's the same size as an area def? Question mark? Okay, let's try it. Assets, compile LDTK. And we have to give it the game world. I guess that worked. So now if I load it, it's gonna die. If I load it, it's gonna yell at me. Especially because I never defined that one missing function. Hold on. I can't believe that these are the same size. 1, 2, 3, 4, 5. These are not the same size. Are they? Wait, 1, 2, 3, 4, 5. Oh yeah, no, they are, because there's 5 here. This is 5, and then there's 4 of these, and there's 2 of these. They're the same size. Perfect. That's maths. That's my rigorous proof. Okay, so let's go into draw.c and define this missing function so that we can run it, so that it can die and yell at me because it doesn't know how to unpack this stuff. And maybe put tile should actually call put sprite, but for now they're probably going to be different. We're just going to say draw to d sprite. We're also going to put a trace in here. Are we? Nah, let's not put a trace in yet. Okay, xy, width, height, u0, v0, u1, v1. Perfect. Okay, now we can run, and now it's going to yell at me about invalid stuff. Alloc failed, level heap overflow, bad, sad time. But that's good, that's what we expected, because when we're parsing this thing, we're trying to read data where it's just nonsense. It just doesn't make any sense. Loaded draw. So we're drawing this thing. We're not doing the middle step. So let's remind ourselves what we're doing, because I'm forgetting. It's a lot of stuff to do. Oh, Bobbius found it. Hold on. You can always rely on Bobbius to find the obscure function you were talking about. Calc size, return the size of the struct. Oh. Added in 3.4. Wow. That's been there for a while. I should know this. So what I really should do, compile LDTK, instead of all these should be globals, and these should be defined as, struct.calc size tile struct fmt or something. That would be better. I'm not going to do that right this second because they're all right at the moment, but I'll do that in a bit. That would be good. It was in Python 2. It took time to get back into Python 3. Classic Python 2 to 3 hijinks. When will it end? When will we just get to enjoy Python, the comfort of Python 2 again? Okay, so this is done. This works, I think. Maybe it doesn't work. We'll find out pretty soon when we do this bit, the bit that takes the thing we just defined, it reads it out of asset.wad, reads the header information, parses the decoration info into this loaded format so that it can be drawn. Let's do it. We're on the home stretch. Easy. Adding all this stuff to a file format's hard. C really doesn't, it makes you do all the work. And sometimes that's good, but sometimes that's really annoying. So let's continue to work backwards. Int load level decos. Okay, so we're gonna have a header. We're gonna need all these things. We're gonna need all these things again. We have the header, we have the loaded stuff. We're not gonna have tilemap defs, we're gonna have deco defs. Deco defs, and we have the level. We need the level. You always need the level. The level that you're loading. Cool, so all we have to do is for int I equals 0, I less than header deco count I plus plus. Wait, did I put? I think I missed something. Header, serialize header. Yes. Okay, hold on. This 1, 2, 3, 4, 5. This needs to be a 6. This needs to be a 6, and we need length of self.decos. This especially is why things were so broken just there. Format.h. deco def count. Okay, yeah, we put it there, but we didn't actually add it. Great, fantastic. Okay, header deco count. So for every decoration in our level, what do? We just need to say, well, we assume that the thing is already allocated. So we say loaded struct target struct loaded deco target equals loaded decos I and level deco defs. Def is header is deco defs I. 1-to-1 correspondence. 1-to-1. Okay, so got to map this stuff. So we're going to say target, and this is here, target position 0 is def local offset 0 plus header world offset 0, right? Resolve the position into world space from local level space. And then do the same thing, but for the y coordinate. Excellent. What else do we have? What's next? Bounds, easy. Target bounds 0 is def. What did I call it? Bounds. Bounds? They're both bounds. I could do this with a mem copy instead, but I won't. Let's do this again. Okay, copy the bounds. Beautiful. Texture index. Target texture index is def asset ref. For now, the only kind of asset is a texture, so this is okay. That is okay. Calc size does not handle any alignment at all. That's also fine. That's what you would expect, right? You would expect it to assume... that's what I want it to do. I don't want it to be like, what if this integer starts 1 byte into the word? Like, no. Give me it nicely aligned. Trust me to be sensible on the other end as well. Everything's packed. Everything's always packed. If you're doing this kind of binary IO, you want everything to be packed all the time. That's good. It would be too much work for Python to do otherwise. Okay, what's the thing that's missing? Texture region. This is easy as well. Target... What's this called? In format.h, UVs. Now, these are uint 16s. Uint 16s. Okay, we're going to mem copy this. Mem copy target texture region. I can never remember. Mem copy. It's destination source n. I'm pretty sure. Destination source n. Destination source n. Yes, good. Destination def UVs, and n is size of uint 16t times 4. But it's easy to mem copy that one. It expresses what we're doing a little bit better. Okay, cool. So that loads it. That puts it into a state where it can be drawn by a level draw function. Now we just need to parse the headers. This is a big function. This is a big boy. This is too big of a function, in fact. We need to split some of this stuff up. Read defs. Okay, so area defs was the previous thing that we'd just read. We need to advance the read head after this. We need to advance it by area def count times size of area level area def. Okay, now we're going to do a similar thing. Struct level deco defs is... I think I really do need a level loading allocator which works from the back, and then we can just nuke it afterwards and pretend we didn't need it, because all this working data just goes away once we've done it. So we're kind of copying, we're permanently nerfing how much memory a level can reference by allocating stuff into the levels heap like this. Okay, so alloc from, and all we're doing, I can probably copy this whole thing. I'm going to copy the whole thing. I'm going to copy the whole thing and then update it. Area. Okay, everything that says area is pretty much going to become deco. Cool. We allocate n times this. Nice, this is good. This is actually really good. I think this is the same thing. I really think this is the same thing. Yeah, or a temporary allocator. That would work as well. Maybe the context in general just has one that I can fill up and trash as often as I want. I like it being part of the levels heap, because if I'm doing stuff async, I'm gonna lock the whole level while I'm loading into it. So if it's part of the same heap and it's just going from the other way, like I'm putting actual runtime data in one end of the heap, and then I'm putting temporary data in the other, and as long as they don't cross over, I just clear the temporary bit after, and then we're fine, right? There's no kind of, I don't have to worry about complicated locking and race conditions. I would usually, for this kind of thing, do a global temporary heap, but because this is loading code, it needs one local to the kind of chunk of the game that it's going to be locking while it's working on. I think that's fine. I think that makes sense. I hope that makes sense. Deco def count. Deco def. Cool, we're going to read the decoration definitions. I should probably pre-calculate this so I don't have to type it as many times, because I really am just typing this same thing a couple of times. Deco defs. Cool, and that's probably fine. Now I just need to actually call the load function, and I need to alloc this. So this should probably actually be part of the hold on, huh? Textures maps. Wait, why did I comment this out? Oh, because, no, I remember why I commented this out. We'll fix this later. We'll just put to do here. I'm gonna run to the bathroom really quickly while I ponder that a little bit. We'll be back in a second. I'm not gonna do a full BRB. Okay, so we need to allocate loaded decos. Alloc from struct loaded deco. Ratchet and Clank's a great option for active vistas, right? Yeah, they always have so much shit going on in the background. How do I actually access Scratchpad RAM? You just access it. It's mapped. It's mapped into memory. Hold on, there's a website for this. PS2 Tech. Does this actually say? Yeah, so virtual addressing, right? Which is after 7,000. Yeah, so it's just anything after address 7,000. 7, whatever, how many digits this is. Mapped in somehow. I don't know. Memory mapper magic. Oh, do you know what's really annoying? This is 2 streams in a row where I've forgotten to do this. I feel like the streams where I have this light on, I have better viewer retention. I don't know why. I like the YouTube videos especially. Level loading temporary stuff should maybe be using that. That's a good point. That is actually a good point. All optimizations to consider in the future once this is working a bit more stably. But yeah, the way I've built my allocators, it'd be really easy to add a level temp allocator that did that. That said, maybe I want Scratchpad RAM to, maybe, because you don't, maybe I build draw buffers in Scratchpad RAM and kick off that DMA. That way, you don't want to be using Scratchpad RAM while you're sending a draw from Scratchpad RAM, because then you get RAM contention. So maybe it's better to keep it in main RAM. I think this makes more sense in main RAM, but I think I do need to use the Scratchpad more effectively for draw buffers and stuff. Hold on. I've also noticed something else. Is that better? Is that smoother? Maybe. My webcam likes to forget its settings sometimes. And I assume... Oh, wait, that wasn't a... Oh, it's a different device. Hold on. Video, I think it's dev video 2. I think it's moved. There we go. Okay. I don't know if that's as noticeable to you guys, but my webcam, you have to set the power line frequency, otherwise it gets some weird interference, and it defaults to 60 hertz, and I have to set it to 50 or vice versa. I think 50 hertz here, right? Because PAL. Rambus go vroom. Yeah, that's the goal. That's the big challenge of the PS2, is keeping DMA flowing. Okay, so we've allocated decorations, load level, alloc loaded decos. And then we have to do this. Again, we're going to copy and paste. Load level decos. And we're gonna area deco. Now, which count did I use in load level decos? Header deco count, good. The loaded one isn't defined till after this, so we have to use the header one, even though they're the same number. That's good. Do you know what sucks? For declaring a bunch of functions. This takes up a lot of lines, and it's just a lot of noise. So let's move this to the bottom. Let's just move it to the bottom. I think that makes sense. After load TGA, yeah. Okay, yell at me. Give me some errors. Deco count has no member named deco count. Yeah, that's good. Deco def. What's next? Come on. Struct level struct level deco defs. Struct level deco def singular. I made the same mistake for areas. And some of these, because they're declarations, you kind of have to recompile straight away. The quick fix list doesn't come in super handy. Level deco def. Okay, hold on. So where? Level deco def. We're doing short names. I changed my mind. We're doing short names. Incompatible pointer type. Level deco def. Psst. Where's this fucking plural? How do I keep doing that? Yep, bracket in the wrong place. Easy mistake to make. Deco defs. Incompatible pointer type. Structurals loaded. Ah, yes, because I decided to do this the stupid way. Where is it? Level. It's just up here. This is up here now. Maps. TGA. Decos. Load. It comes after loaded for some reason. For some reason. Consistency is bad. Maybe we should all try being less consistent. This should return 0 if everything's okay. And is that good? Does that work? What happens when I run it? Let's find out. Errors. Of course it errors. There we go. Okay, what's the error? What's going on? Error, level heap overflow. Oof. Offset, name length. Yeah, bad. Bad stuff. Bad stuff happening. Okay, area def size, loading assets. Cool, so that's good. That's good. That's because we've corrupted our headers, and that's fine. Heap size, cool. Yeah, I had to do this the stupid way. That's what I'm always saying, right? Do things the stupidest way possible. Just start like that. You work it out from there. Read tilemap defs, read asset defs, read area defs. Area def size, good. Loading asset, kind. So the kind is wrong, the name offset is wrong, and the name length. It's all wrong. It's all wrong. So let's look at this asset. Entry 01. Let's look at it under the microscope. This is good. These still are correct. I don't know why there's so much padding afterwards, but that's okay. We don't care about a little bit of padding. No deco def stock got read. We died before we got there. We died before we got there because we've somehow corrupted our header prior to that. We've corrupted our asset definitions. So what's going on? So entry 01. This is our level name. This is good. And that's all good. Then we have all these zeros. This is extra space for the level name. Then we have tilemap definitions. So it should be somewhere in here, right? So let me just double check. Deco def size. We didn't actually write any deco definitions. We didn't actually write any. And also, this doesn't even take a data chunk. Easy. Tile is not defined. Okay, here we go. Here we go. There were actually problems in my code all along. I don't know why that broke things so badly, because... We'll see what happens though. We'll see what happens. Let's unpack this and rebuild a correct WOD and then go from there. Texture name. Let's just call this tile then, because that seems to be what the name I've used everywhere else. Cool. Texture name. Asset not defined. Name. TS lookup. Yep. Get rel path. That would do it. Asset not defined. That's because it's a PNG, not a TGA. We need to rewrite it. And we need a function to do that. Def rewrite TGA. Rewrite PNG. Return s replace .png TGA. Just replace it. Okay, so we're going to make this automatic as well. Get asset index. If we get to the end, we're gonna if a equals name or a equals rewrite PNG name, right? So if either name matches or the name matches after we've converted a PNG to a TGA, a target, that's better. Except I want that to be in brackets. Self.assets. What are these assets? What's going on here? Oh yeah, they're never... That also makes sense. So we go over... For everything in textures, we need to add all of the tileset textures as well. We need to make sure they're all present. Make sure they're all present. Maybe there should be a... I wonder if we can turn this into a set. I wonder if we can turn this into a set. Enumerate that. This all should be okay for a set. We're gonna make it a set because we want it to be unique. We don't have to worry about. We don't want to have to worry about duplicates. Now look, let's go for a list. Let's go for a list, but let's make it a set-like thing on the inside. Let's make it. Let's go down here. Levels. So in a level, we get all the level textures. I guess I guess we already have all the information we need. We already have all the information we need. So what we want to do is look at all of the entities in the level, and if they reference a tile set, add the name of the thing. Deco entities. Add a decoration. When we add a decoration, the problem is when we serialize. Okay, so when we add a decoration, we also want to say. We want to do this down here. We want to do this thing from down here. We want to get this name, get tile, every decoration, texture name, and then we want to level asset, rewrite the name like that. We want to say level add texture asset rewrite PNG texture name. Okay, so now it's an asset in the level. For every decoration, we do this. We do this. And we should probably collapse this check, but that's okay. Now it's a little bit better. Self is not defined. 142. Oh yeah, self. So tile set lookup. Perfect. Okay. There we go. There we go. Adds everything in together. I assume that's going to work okay. So now what happens when we run? It might work. It's drawing from the wrong texture, but that's okay. That's something. Oh, hold on. Well, we've got an error when we try and draw a sprite, so that's good. That yells at me. Good, good. But that might just be because the return code's wrong. If put sprite, draw.c, put sprite, return draw2d sprite. I think that draw2d sprite has a different. I need to work this out. This is going to be a real problem. Draw.c, draw2d.c. What do we return? We return 1 on OK. Okay, okay. So we want to say if not put sprite. There you go. Perfect, perfect. So this is good. This is progress. It's drawing a thing. It's just drawing it from the wrong part of VRAM. It's nice. That's nice. We're also not drawing our little debug areas anymore, so that's also good. Okay. Why is this the wrong thing, though? When we serialize the decor, actually no, let's just debug it like this. Let's do a log debug. Deco texture name equals, or texture index equals D. Index is 1. Excellent. That's good. So oh, okay. Well, let's actually upload all the textures. That's even better, isn't it? Let's make sure we bind the texture as well. So we never upload it, and that's a problem. Gotta bind it here. For int I equals 0, I less than loaded texture count I plus plus. We're gonna upload every texture. Text is loaded textures I. We upload it. Then we bind the tilemap texture before we draw the tilemap, and then we make sure we bind each texture before we draw the thing. Perfect. There it is. There it is. There's our big gooey orb. Let me move it and rebuild the level. And then the real test, does it PS2? Oh, well, so that didn't work. Okay, hold on. For one thing, let's get rid of this stupid log debug. I need to make WAD first. Now when I rerun, the orb should move. It's outside. Look at that. That's beautiful. So now we can put arbitrary decorations outside the tilemap in the level. And then just get managed in VRAM. The assets get linked together. The asset only gets loaded if it's part of the level. This is good. This is good stuff. This is good stuff. Let's head over to the PS2. Let's head over to the PS2 and let's do it. Let's do it. This is weirdly productive for me. How am I capturing it now? I got a capture card. I got a capture card that looks actually kind of okay. It's interlaced, so it's kind of shit, but it's also kind of good. I'm gonna set this up. As I do more work in this game, I'm gonna set this up to distribute potentially. Oh yeah, right. That's a loading zone. That's okay. It's allowed to pick up there. Once I have a better setup, I'm gonna set this game up so that you can run it in 480p DTV mode, but this Seems good. So let's go back, right? Let's move this again. Let's add a couple more of these orbs. Let's actually add one into another level. I think that's probably worth doing. So let's copy and paste this. Let's make one big and just see. So we got one that's big and one that's little. And let's also put an orb decoration, I don't know, right around here, right? Just to test. Okay, so make C source WOD. No, whoa, that's wrong. Make WOD. Let's reset the PS2 if we can. Let's see if that worked. Yep, good. So we have, whoops, wrong scene. We've made our WOD. All right, let's see if we can run it. Let's see what happens when we run. Are we gonna see more of these orbs around, or have we blown up the world? Bobbius says nothing. I can't drag chat onto my screen here. Okay, so we see a really big orb. That's good. That's good news. I need to actually change my monitor over to the PS2. I can't play on the OBS delay. So we have this big orb, we have this little orb, we have this loading zone where we're going to freeze for a bit. Maybe next stream will be multi-threading. That would be good. Now that we've got this, I guess the entity system is kind of important as well. Then we can come in here, and there's a big orb in here too. Beautiful. There's a little shiny pixel in the top left corner of it, but other than that, it's looking nice. You can see the UV alignment for my tile set is a little bit off, I think. Actually, it's looking pretty good today. Sometimes it doesn't look as good. I think these tiles down here look worse. No. Weird. It actually seems to have fixed itself. That's mysterious. Earlier in the stream, these were like really poorly aligned. Weird. But yeah, still working on D stuff. Bobbius says, getting flashbacks to trying to get your... So Bobbius has written a QOI image decoder in D, which is really cool, and it's working now, despite despite Windows' best efforts. Drawing a black screen, you had no idea why, because the render doc showed the texture was being uploaded. Yeah, that's always hard, right? It's like, God, sorry, I'm trying to play this off my stream preview. Let's go back. Cool. Let's go back. It's nice when you have a little thing and you're just jumping around and you can enjoy it when you get to that point in the project. Cool, and I love that you can see, like, this is logging coming from the PS2. So let's reset the PS2. I have to press some random buttons to make that work for some reason. Come out again, changing something that had nothing to do with it, and it started working. Yes, beautiful. That's my favorite kind of bug. I recompiled it, and it shouldn't have fixed it, but it did anyway, and I just take it. Yeah, started working. I had a problem like that. There was something. It always happens in compiled languages. I don't know why. Oh, cool. So that was weirdly productive. We did it. We did this. Decorations and levels, done. Cross it off. Load entities. Now, a better entity system is kind of important. It's going to be very important. Because we want, there to be like other characters in the world. And the way we do that is complicated because we're going to have to think about what scope they live in, right? Do our entities local to a level or the overall world? Do we like kill entities when a level unloads? How do we manage that? How do we manage making sure we have room for more entities? And these are all complicated questions. They're all very complicated questions. And questions that would be nebulous to answer. But we can definitely start to... it's hard. It's hard to know exactly how we should deal with that. And I don't know if that's a question I can really answer today. So maybe it would be fun to start thinking about some threading. I don't know. I actually think I need to clean up some of this code. I think some of this code is a little bit ugly and needs some cleanup, especially this file, because we have two things happening in one file, right? On one hand, we have all of the loading. We have all of the loading, all of the like file IO stuff, read the headers and initialize our structures. But then we also have the code that like draws the loaded level. And I guess they're related, but yeah, I don't know. Work. Very confused. Yeah. So literally sometimes you just need to do a make clean and make build again and it works. One thing that's really bugging me about this code in general. So let's maybe commit what works. Levels. fmt reads decorations, source draw, add put sprite, and then we want to add compile LDTK and assets LDTK.py decorations into LDTK into level files. Cool. Nice. Okay, well that's nicely done, right? That's important. That's important. So now, one thing I think would really be nice to do, one thing that would be really, really nice would be that these allocations actually happen inside the respective load functions. So inside load, and they're above now because forward declaration sucks. Inside load level maps, I think the first thing we should do is allocate. And I think that looks way nicer here. It's much more local to where it's actually used. I think this is better. Header, asset def count, size of EU texture. I think this is good. I think this makes way more sense. Way more sense. All right, areas. Load level areas, that's up here. And then we just need to change the header into an arrow. Alloc from, it's one of many alloc froms. Decorations. Cool. This is just nice. This is just better. Cleanup time, exactly. You've got to make sure your code stays clean. Level decos. Otherwise, you just get into a mess. This has been looking at, like, I've been staring at this in particular for the last, I don't know, 2 hours of streaming, and I keep thinking, this stinks. I got to do something about this. Nice. Okay, something went wrong there. As a def's undeclared. Huh? Oh. Hold on, I copied too much. The man who copied too much. That's not right. Wait. Load level, load maps, load assets. Oops. Nice. That just means I never, well, that's also not what I wanted. Okay, there we go. That is nicer. The Man Who Copied Too Much, a classic fable. I've definitely read that one. Okay, allocations now happen more local to the data we're loading. Everyone is happy about this. This is a universally good thing. Now, it's time to clean up some more craft. This to-do is really glaring at me here. I really want to clean this up. Load level maps, load triggers, load decos, load assets. I think we should load assets before we do anything else. I think assets should come first. Not that it really matters, but I think it feels like a better order for stuff. Cool. This is good. Loaded level bounds. We can get rid of that because that's kind of printed out anyway. Okay. Allocations, it just reads a lot better. This function, the shorter this function is, the happier we are. Now, let's go into context.c. We have this thing where we have one tile map for decorations and one tile map for collisions, because if we go into a level, the way we've done this so far is every level has a collision tile map and a decoration tile map. But what if we want a foreground tile map that draws in front of the player and a background tile map that draws behind the player? What if we want multiple collision layers inside a level? There's lots of stuff to consider, right? And I'm pretty sure that I can add a layer. No, these happen in the whole project, so these aren't level specific. So that's interesting as well. But we might want more than 2 layers. If any one level wants more than 1 layer, they're all going to inherit all these layers. So maybe we need some kind of check, right? So, maybe, well, I don't know. Maybe they don't. I wonder if I add a layer, right? This is an LDTK question, not really a PlayStation 2 question. If I add another layer and I say, hey, this is the foreground. This is stuff that's like really in front of everything, and it's these same tiles, and that's okay. And then we start putting stuff down. Does that tile set, like, is there an instance of that tile set here? Because we can still draw on it here. It still exists, but there's no data in it. So if LDTK isn't smart enough to filter that out, we probably need to filter that out. So foreground, right? So this happens up here. So let's add that. So this model where we have 1 layer for decoration and 1 layer for collision, it's a little bit outdated. That's not how we're going to do levels anymore. Oops. Let's ignore that. That's not how we do it anymore. It's now up to the individual level to manage drawing any tile maps. And a level could have lots of tile maps. It could just have 1 of each. And not every level has to be loaded from a file like this. We can actually just, like, the way this level is implemented, it uses a more general level API. This idea of a level is not tied to the file we're loading. The level we're loading implements this kind of structure in such a way that it behaves like you would expect from the loaded level. But we could write our own levels that have our own draw functions, that don't use tile maps, that don't do any of the things that our levels currently do. The reason I've done it like this is for flexibility, right? Maybe, and I guess a classic example would be like a boss level where the rules are kind of different. The way you draw things might be kind of different. It's a little bit more limited in scope in a way, and you might need special things to happen that you can't really represent in LDTK. Maybe, or maybe not. Maybe I'll never use it, but it's good to have the flexibility that I could just write random code. Like if you want a level where the tile map changes as you move around, you could do that here. You can't put that in LDTK, but you could put that here. That would be cool. That would be cool. Okay, so. I forgot what I was doing. In format.c, now we're going to have this problem. If we look at our load level maps, now instead of this, we're gonna come into this world, and we were just kind of getting pointers to these things, but we don't want to do this anymore. We don't need to do this anymore. What we actually want is to do this allocation, right? We want this. So textures. Wait, that's wrong. Loaded textures should go in load assets. My mistake. I got a bit jumbled there. I got a little jumbled. Okay, there we go. Decos are allocated in decos, assets, textures are allocated in assets, and maps are allocated in maps. Good. This is no longer relevant. Tilemap def, tilemap kind, and now target. Our target is going to be loaded maps I, right? The ith tile map. That's what we're doing. Now, I think we need a second list as well, or maybe another type. We'll say struct loaded tile map, and this is just going to be a struct tile map with an extra field that is an enum tile map kind. You can't really use the word type for stuff, right? I could use an entity to hold custom info to help custom. Yeah, you could, right? You could, but I prefer to write code. I prefer to always have the back door to write code. Like, I might end up building this, but if I ever decide that that's too much bullshit, I can just drop into writing code, which is where I'm most comfortable. And I think it's always good to build things with that escape hatch in mind, right? It's that idea of, building around an interface rather than hard coding everything into an exact kind of logic flow. And there's nothing wrong with having, function pointers. Some people are like, function pointers will kill your performance. And it's like, well, yeah, but only if you call them enough times in a frame. Interface in C. Well, I mean, that's basically what I've done, right? It's a struct with some function pointers in it. It's an interface. Interface in C. What is this? Java? This is, better than Java because I can make things that aren't classes. The worst thing about Java, everything being a class. Tilemap one word kind. But then the struct is a tile underscore map. That's good. That's very good. Maps loaded tile map. Okay, so now everywhere we have maps, this is now struct loaded tile map. Loaded maps. Good. Struct loaded tile map. Target kind is kind. Asset ref header deco map. So this is the other thing we need, where we're gonna say uint32t at texture index if it has one. If it has one. So now we say target texture index is the asset reference. Good, so we're going to get the memory address of target tiles. And that's all we do. And then we just need an extra indirection here. Beautiful. We need the memory address of this. We just copy right in there. Right in there. Zig does interfaces using structs and function pointers. Good, that's the right way to do it. It's kind of like how Rust does it, right? I mean, it's how every like Java does interfaces using structs and function pointers under the hood. It just gives you a really clunky interface to it in the guise of everything, in the guise of oops, solving all your problems ever, which, you know, it is a lie. Okay, so if it's not equal to this, blah, 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 and if it is equal to that, we just set it to that, and that's fine. And if it isn't a decoration map, then that also doesn't matter. So that's good. That's good. Local offset, blah, 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 blah. This all feels good. Okay. So the only missing thing now is to update the draw function. And in the draw function, instead of just drawing one tile map and hard coding it like this, we're going to say for int I equals 0, I less than loaded. What did I call this? Tile map count? Need to decide on if there's an underscore between tile and map. That's a bit of an inconsistency. Okay, so if, let's say struct loaded tile map tm, this is our loaded maps, our ith loaded map. We say if tm kind is map deco. If it's a map that we actually draw, let's say if it's not equal to this, then we just continue. Otherwise, we're going to grab the texture like this, new texture, and it's going to be the maps texture index. Let's say, do we do this check? I guess we do this check. We do the same check, except now it's tm. Draw tm tile map invalid texture, texture out of bounds, texture index, loaded texture count tm. We grab the texture from our loaded textures, we bind it, and we draw a tile map. Excellent. And now this is tm tiles. Grid size with our texture and our camera. Beautiful. And now, of course, something's gone wrong here. That's okay. I always forget that semicolon. Easiest mistake to make in C. Everyone does that all the time. Very, very common. Header, tilemap def count. Yep, that's got to be a pointer. Don't want to record a macro, thanks. Okay, maybe something went wrong there. Let's make run not from within Vim, because otherwise it's impossible to read the logs. Okay. What? Start PC, core dumped, aborting application. I suspect that's not my code. What the hell? Rec recompile. Huh? Okay. That's weird. So when in doubt, run it in Valgrind. We can't run Valgrind on an actual PS2. So what we're gonna do is platform equals PC. We're gonna build a small test that I have for the PC. Level test. Now there are, of course, a couple of issues. Game context C. Yes, context C. Okay, so we changed a header and the corresponding C file did not flag that something had gone wrong. So this might be the issue. I've got a feeling this actually is the issue, and we don't need to build for platform PC anymore. I think we found the problem. Yeah, nice. Okay, set tile. Shared set tile. Oh, but that's not that important really. Shared, level shared. I don't know if I'm really using this anymore. I think I can just delete this. There we go, context.c. What's going on here? Level context has no member named collision. This is correct. Collision width, collision height. Now, this is important because I forgot I was relying on this. I was relying on this exposing a tile map called collision. Okay? This is kind of the primary port of call. Now, we could hack this. We could kind of do a bit of a weird hack here and say that... Maybe say that the level has to... Okay, so there's two options right now, right? There's two options. Let me go back to here. There's two options. Let me turn over a new page. Oh, this is my file format. Let's turn over another new page. So previously we had a level, and the level had a collision map and a deco map. And when we draw, we look at this. And when we test, collisions, we look at this. Now, there's two options that we could do here. One is that, because now a level looks like this, as far as we're concerned, right? When we draw, we call a draw function that's part of this level. So we no longer know what the data is, we just use a function that knows how to interpret this level's data. But the draw system does not really know what's inside here, right? The context no longer sees the stuff inside the level that we're drawing. So there's two options. One is that we could make a collision pointer, because internally we now have maps, right? And when we call draw, it reads into this, and it finds the ones that are drawable. We could make a pointer for our collisions that points into maps, and we could use the same kind of API, test point, whatever. Or we could do it still in this kind of virtual way, where we could have a function called test point, I guess. And that could work out, like the level works out how that calls into that. So we have two options. We can either map data into these maps. And I think I prefer this because this is more flexible in the future if we have multiple maps with collision, if we have, you know, different stuff. I think that makes sense. I think that's kind of good. So the old world, they were hard-coded maps that existed, that were places in memory. The new world, we don't know how a level manages a heap. We don't know what's in its heap. We don't know how many maps it has. We actually kind of do, because it looks like all levels have to have the same number of maps. But other than that, we don't really know. Actually, let me check that real quick. So levels, entry 01, layer instances, has a foreground layer with stuff and tiles in it. Okay, so what about the next? We have a collision. Where's our next level? Hold on. Levels. Where's our next level? Entry 02. It has a foreground layer. Okay? That's not great. So I guess we need to check if int-grid CSV and grid tiles are both oh, I'm on the wrong scene. Thank you, Bobius. Always the guy to see it. So what I was saying is, this layer is now present in all levels. However, if I look in a level that doesn't have anything here, it still has this layer as an instance, it just doesn't have anything in it. So we need a way to check if a layer is empty. That's going to be important. Otherwise, we're going to have a lot of duplication and this whole system is going to kind of be pointless. The idea is that, you know, we have limited VRAM. We can't have every tile set loaded all the time, but it'll be a layer. Cool. Cool. And when we want to do depth, layer depth, which we can probably define, right? We'll probably have to do it something, edit layer settings. Can we add properties to a layer? Maybe we can't. Weird. Huh. All right. I'm going to take a quick break. And then when I come back, we're going to fix this. We're going to finish this. We're going to do this. We're going to do the virtual function way. I think that's better. But I am going to take a quick break. And while I'm gone, let's do a Quake demo this time. I think that was a good suggestion. I think that was a really good suggestion. A break, I'm a human being. We could do one of my games. They're probably not very exciting, unless it's like random FFA. What's a good Quake demo? Quake, something retro maybe. Quake 3: The Legend, Russian, 4-on-4, MC3. I don't think any of these have any files in them. Who's playing an Asus Spring? Cooler? Malloy versus Cooler. Whose point of view is this? Malloy's? We don't want to see some scrub. CPL London. WCG Russia. Death versus Pele. That's kind of classic. Alexa versus Pele. That's also kind of classic. All right, Wolfcam. Pele Alexa. ZTN DM3. I'm pretty sure I have this version of the map. All right. Wait, that didn't work. Hold on. I'll be back in 1 second once I fix the scene, all right? All right, we've hit garbage time. That's a fun game. That's a fun game. I don't think I've seen that one before, but yeah, I don't know what year this is either. Actually, WCG Russia, probably 2002, something like that. Yeah, you know, at a time when it was not easy to make Lexa look like a chump, especially not on ZTN. But yeah, you know, garbage time. Well played, well played. What channel is this again? What am I? Is this my Quake channel or is this my programming channel? Tom Monks Talks Quake. Okay. Welcome back. Thank you. You laugh. I don't know if you know this, Bobbius. I don't know if I show this off very often. I started doing videos. I started doing Quake videos again, right? Oh gosh, this is dangerous. Talks Quode. I should make a Quake clone. I should do it. Hold on, let me, not that channel. Gosh, not that channel. I've got some funny YouTube channels linked to this account. Old things that I've put on the internet in my youth. Let's not do analytics. Let's actually bring the channel up. Your channel, not my. But I do Quake videos as well. You know, if you ever wanna watch some classic Quake games, this is also me. Some of them I went through his patch a couple of months ago, and then most of them are old. Most of them are quite old. What's doing well these days? Dusk Movement got popular. There's me, circa 2016, I guess. Scarf Boy. Yeah, you know, my other thing. If you're interested in Quake, might do some other gaming stuff on there at some point as well. But yeah, you know, good game, good games to talk about. Worth a look in my opinion. Lots of Russians. Evil comeback. I'll heart that. Phenomenal. Okay, awesome. Back to code. Serious mode. So, I drew this picture just before, and now I'm looking at it and I'm like, what was this about again? What was I doing? So, rather than having two maps that are hard-coded part of a level, I'm going to add an API to our level, another virtual function, if you will. Level test point, which is going to take a game context, a level context. I don't know if we need the game context, actually. I think we can just take the level context, and then we'll say float x, float y. Is this point inside this level? And we should probably also have test area, but we won't do that right now. And actually, test area would be a better way, because I think right now we ask the camera. Does the camera contain this bound? But it would be better to ask the level, does the level contain this camera? Or does the level overlap with this camera, rather? Contain is a dangerous word that can mean lots of stuff. But for now, we're just going to do test point. Level test point fn. Level test point fn test point. And then we can test a rectangle by testing 4 corners and assume that rectangles are small. Levels are big and rectangles are small, so we probably don't have to worry about testing things that are wider than a level, right? Because in a game, usually levels, like, we're not going to have some tiny level. Maybe we will at some point. But test point is probably enough. Free point, free box. Okay, we can do this. Context.c. Now, free point, instead of being hard-coded like this, we just say for int I equals 0, I less than level max I plus plus. If, let's say car t, let's say int hit equals ctx levels I test point, the level that we're testing, the x and the y that we're testing. If hit, return hit. If it returns 0, we return nothing. And then at the end, we say return 0. And now this behaves the same way, right? Because we're just testing for free points, which is great. Your most popular on YouTube has 2.6k views. What's your most popular video on YouTube? What did you do? What's your claim to fame? 2000's not bad, right? 2000 individual people in the world. Like if you drew a paint, if you made a painting and 2000 people looked at it, you'd be pretty happy, right? If you like, there's lots of, you know, I've probably played to audiences bigger than 2000 in music. Maybe somewhere. But you know, if you play music to 2,000 people, you're feeling pretty fucking good about yourself, right? Yeah, so you know, like 2.6K, that's a lot of people. That's a lot of people. Replay of a rhythm game. That also sounds relatively low effort as far as content goes. 2.6, that's fine. That's fine. Most of my videos do worse than that. You know, like that's good. 2.6K is good. It's not all about blowing up. Rhythm game. Yeah, sorry, I would ask more rhythm game questions, but I honestly know nothing about rhythm games. But it's a chat is interested in rhythm games, so that's good. Glad you found your people. Cool, so now we just need to implement this. And we get rid of that. Okay, so. Oh yeah, and then we also just get rid of that. Cool. Oh, and I guess the other thing we do is free point. Before we just go barreling in here, we probably want to say if it's null, just barrel on forward to the next level, right? If it doesn't have a way to define testing a point, meh, we just ignore it. That's okay. So then when we free a level, we probably want to make sure that we clear all these pointers, right? Active is 0. Oh yeah, that's the other thing. We want to check if it's active. But we probably also want to say draw is 0, update is 0, and test point is 0. We want to clear all those pointers, because otherwise bad stuff might happen if we load a level and it doesn't zero them out for us. Update, cleanup, draw, test point. And then we probably also want to say x cleanup equals 0. After we've cleaned it up, right? After we've cleaned it up. Good. Osumania, Osu, video from 2012, nice. Osumania, IIDX, charts, we've been playing, nice. PS flip top mod your PS2 to playing ported copies of a game. Nice. IIDX. I don't know IIDX, but nice. I love a good PS2 mod. Yeah. Okay, so we're freeing levels better. We're cleaning up a little bit better after ourselves, and that's good. And I think we're ready to go. I mean, so if I do this now, right, I should be able to make and levels I dot test point. Sorry, this should be a dot because it's a pointer, but it's not pointed to. Okay, so now when we run this, we're going to fall through the floor. We expect it all to load. Okay, we've compiled some code that is bad. That's weird. Yeah, there we go. So our tile maps are a bit broken. That's okay. 102.8 AC. What's at 102.8 AC? We've got some segfaults. 102.8 AC. What is this? 102 A8C. I can't read. 102 A8C. I probably could have just scrolled down to that. This is get tile. Okay, so where are we calling get tile? Stack. Let's put a breakpoint here. Let's run again. We break on this breakpoint. Cool stack. Where do we call get tile? What function is this in? This is in draw tile map. And then this is being called from I don't know where. Okay, because we broke the backtrace. That's good. That's good. So draw tile map is freaking out on us. It's wigging out. And that's probably because we haven't allocated something properly. Let's go into tiles.c, let's go into draw.c, draw tile map. So if not tm, that's good. What we should also check is if not tm tiles, right? Because if we look at tiles.h, this is a pointer, okay? And we got to check that as well. tilemap data. Now this is going to give us an error instead of a seg fault. Or not. Okay. So that check didn't really mean anything. Let's tgame.log. So what's the first thing that goes wrong here? What's the first error? What happens? We print some stuff out, we finish loading it, and as soon as we start drawing it, we start spewing out these put tile errors. DJ Oslin, thank you so much for the raid. Welcome. We are currently... Oh, welcome. Emerald Sniper, welcome. Nitro Raid, thank you. DJ Oslin, counter raid. Yeah, I've been raiding you a lot lately. I'm digging the cars. This is a fantastic emote. How is your car game going? For people who don't know who DJ Oslin is, hold on. You should check out it. What's your game called again? I'm really sorry. I'm blanking on the name, but it's a great name. It's a great looking game, rather. Nitro Thrash. That's it. That's why you said Nitro Raid. Hold on. Let me click through this stream and see if I can find some car action. Like this game just looks great. It looks really fun. I'm looking forward to playing it. Car stunts. Very, very good. Very, very good. Check this game out. Nitro Thrash. Seriously, I love this. I've had a lot of fun raiding him. Car skateboarding game. Yeah, pretty much. That's how I understand the elevator pitch. How's it going? What were you working on today? I wonder... So this is a seg fault, right? And we have a couple of pointers here. We have the tile map as a pointer, the tile map tiles as a pointer, the texture as a pointer, and the camera as a pointer. Now, we only check... I guess I should check all of these pointers for null. I guess I should null check all these. You've been messing around with new ideas for the next level. You've been deathly curious to see what PS2 development looks like. Let me show you what PS2 development looks like. PS2 development means you write code for like an hour or two, and then when you run it, this happens. And you get TLB misses, which means it basically would be a seg fault on a normal, on like Linux or something, right? Where it's trying to read a memory address that isn't real. It's trying to read 6060A95. Now, that is strange, actually. That is strange, because I don't know where we would be getting this address from. Like, so it's not a null pointer. If it was a null pointer, this would be 0, and we would actually probably just crash the whole program. So this null check doesn't really work, does it? So let's go back. And I guess if you're interested in PS2 development, you've come at a really good time, because I'm about to reach deep inside the heart of the PlayStation 2. Let's go into the debugger, okay? And let's go to this address, 102AE4. 102AE4. Okay, so this is in my getTile function. Now, getTile, what does getTile do? getTile just looks at the tile map, right? So it just does this index. So it's possible that our width and height for the tile map are incorrect. That would be worth checking. Maybe we should log that out every time we call getTile. Put a log inside there, and then we'd know. Okay. But where does this happen? So 102AE4. AE4. Okay, here. Load word. Load word from A0. A0 is going to be a bad pointer in this case. So if we run, this is our breakpoint. We've broken here. We can see what's in A0. 3809D8. When we step over this, that maybe is not the okay, so some of these are okay. But that one, okay, hold on. So if we keep running this, we should eventually see bad addresses. Hard to really know. I guess, what if we break like at the start of the function and step through? Because another one comes out, but seemingly 102AE8. Interesting. Specific FG you shall not name. PS2 related ones are intriguing. PS2 development looks a lot like my language development. Yeah, stuff going wrong and me not really knowing. Also, sorry, this is a PCSX2 issue where you get this weird screen corruption when you drag stuff around. Okay. I have a solution in mind. I have a solution in mind. Every time we call get tile, which we call draw tile map, put tile, t. Where does t come from? T comes from get tile. Okay, so every time we call get tile, tiles, we want to just log this out for now. So let's say, and we should be checking this, so that's okay. Log debug get tile x, y from map. And that map is d by d in size. So x, y, tm, width, tm, height. Lots of crawling through assembly. Yeah, you can't be afraid to get your hands dirty if you want to master the PlayStation 2, right? You gotta be bold. You gotta be bold. Okay, so now if I run this, at the very least, we're gonna get log messages before all of our misses. 74 by 16, and that's okay. I guess the other thing to log out, and then we'll know, is the actual tiles, the pointer, right? This is gonna give us the address, and then we'll be able to really see. 6060606. That feels like a bad address to me. So let's look at where we actually allocate this. Loaded maps, alloc from, that's good. And then down here, down... Okay, I think I see the problem. So the target is a tilemap wrapper. I don't think we ever actually set, like we do this read, right? We read it out into here, but I don't think we ever actually allocate. So we work out the size, then we should really say we should say target tiles.tiles is alloc from level allocator. We want to allocate the map size. We just want one of them. So if you actually allocate the memory you're trying to use, that usually helps. Now we've got an issue still, and I don't understand why. I really don't understand why. Because yeah, it just feels okay. It just feels right. Load assets is okay. Load level maps. So the maps, this is enough space for all of the data about the map, like the width and the height. That's all good. Load maps. So we're kind of copying from our definitions into the runtime data. We do linking of assets if we have to. That's kind of like a load time step. We initialize. Oh, but this calls. This does this alloc. This is already called in tilemap init. That's why we pass an allocator in tilemap init alloc from. Okay, so that's not the issue. That's not the issue. The issue is alloc from appears to either be returning garbage, which is possible, which is very possible. So as soon as we initialize this, let's log the pointer. Let's log target tiles, the address of this. Wait, no, it's not the address of it. Oh, that's the problem. I'm taking an address of a pointer. I just want the pointer. Okay, so now it's going to run. Now it's going to be fine. There we go. Okay, that will do it. That will do it. Now we need to get rid of this log, because otherwise it slows everything down so much. Okay, we're kind of inside the world a little. That's okay. I don't know why. Yeah, and you can see what confused me, right? Because this is a pointer. This is a field within the pointer that is not a pointer. So we get this, but this is a pointer. So it's like a pointer to a not pointer. So we use dot. And usually when you dot and you want to set data somewhere, you need to take the address of that thing. But in this case, we don't. Visuals, very ugly visuals. That's just my ugly tiles, but yes, visuals. So just for the people coming in, by the way, one of the main things I'm doing right now is a workflow where I can define stuff in LDTK and then load that on the PlayStation 2. These are 3 different level zones I've got load zone set up, so like in this one, when you cross through this area, it loads in this part of the world. When you cross through this trigger zone, it loads in this part of the world. So the idea is you can have like a big smooth scrolling world, edit it on the PC, and then load it into the PlayStation 2. And that works. That all works. You may not believe me right now, but that does in fact work. Cool. So we need to go back into context.c because this test is now doing something funky. If this isn't defined, we continue, and this should be okay. I'm gonna do something silly, and I'm just gonna always return 0, and then we should fall through the world. But we don't, which is very mysterious, because you would think if we always return 0, oh wait, hold on, it's the opposite. It's the opposite. Is free. I didn't read. Important thing when you're dealing with your own, even when dealing with your own code, you still have to read sometimes. So if hit, return 0, right? If we hit something, this point is not free. So now we're going to fall through the world because I haven't told it to check collisions yet. It's the responsibility of each individual level to work out how it wants to check collisions. Kind of. It's complicated. It's kind of hard to explain, but it'll all make sense eventually. It's a lot of stuff to wire up. So this is all just like reading headers and level info out of files. What we need to say is level test point is loaded test point, right? We're gonna wire up, it's kind of like an interface. It's kind of like an interface. So we're gonna go static int loaded test point. We need the level, and then we just take a float x and a float y that we're gonna see, we're gonna test to see if it's free in a collision map. It's gonna look very similar to this. Very, very similar to this, except instead of texture count, we're going to loop over all of the maps. Tile map count. And then we're going to have to do some very similar stuff to the draw loop, except instead of looking for maps that are decoration maps, we're only looking for tile maps that have collision. Because there's two kinds, right? They have the same representation in memory, so we're going to treat them as the same thing, but when we're looking at collisions, we only look at maps with collision. And then we say, if it's a collision map, we test if tiles... We need to do this lookup ourselves, apparently. Get tile world. Now, get tile world, I'm pretty sure, is the thing... tiles.c get tile world. Yeah, this does the lookup, which is good. So if get tile world, we pass in our tile map. We pass in our tile map tiles. We pass in our x, we pass in our y. So if this is non-zero, then we return... Oh, but now this is inverted again, right? That's okay, that's okay. We return whatever, no, if it's non-zero, we return whatever the value of that tile is. If hit, return hit. That's what we want. Otherwise we just return 0. Not if hit is non-zero and hit is not tile invalid. That's the only other thing we need to check. Tile invalid. Okay, there we go, there we go. So, does this build? No, because I need to forward declare this. Now it should build. Warnings, int, texture out of bounds, texture count, texture index, texture count. Okay, let's fix that because that's very fixable. That's a very fixable warning. 414, we've seen this a few times. All this means is that it wants it to be an LU instead of a D. If you've ever done C stuff, okay, it still maybe didn't like that, but that's okay. And now it looks like we've got collision. Nice. So for the people just coming in, do you guys want to see this running on a real PS2 through my capture card? Let's do it. Let's, nothing can go wrong with this, right? So what's currently happening on my PS2? Nice. So this is a program called PS2 Link, and when we run, let me show you the command. Well, actually, I mean, it's just a makefile rule, but I can run PS2. That's going to hook up to my PlayStation 2. And then we're going to get, this is just kind of like the old frame buffer. There we go. So we're running. Beautiful. So these big circles, they're just kind of like my test decoration, right? But this idea that I can have tile maps, but also things that aren't tile maps that are just part of the level. When we hit a loading zone on hardware, it freezes while it loads because it's not done async yet. That's kind of one of the next things on my radar. So that kind of sucks, but that's going to happen. That's going to get fixed soon. So this chunk was loaded in dynamically. Now, let me demonstrate the level loader in action. Okay, so there's this kind of like grassy section. That's kind of what I was thinking of. Very dark dirt. Classic DVD latency, yeah. Well, this is network latency because it's loading these files off of my computer even though it's running on a PS2, which is kind of awesome. So there's that grass up there, right? And we come down, if we hit the next loading zone, so from here we can see that level section we were just in, but if we hit this loading zone and it doesn't crash because the connection hasn't timed out, which happens sometimes, that's good, that's nice. I think I upped it to like 5 minutes before it times out, so that should be unlikely. Now you can see that section to the left is unloaded. Because, you know, I haven't designed my loading zones carefully to hide that. So we can come down here, there's this area down here which has just been loaded in. All of my tiles are really freaking ugly, but they'll get better. I'll draw nicer stuff. This was all just for testing purposes. Nice. Now, there's a problem here, and that problem is that all of these level areas contain more layers than they need to. Even if a layer is empty, it's going to be present, and this is another loading zone, it's going to be present in the set of maps that this level has. So in our LDTK to PlayStation 2 compiler, what we really want is to filter all of those out. Musha68K, thank you very much for following. Also, actually, one of the layers that should be here is actually not here. It's kind of weird. That shouldn't happen. So if I come back over to my screen, we'll investigate this layer. This is actual logging output from my PlayStation 2, which is also really cool. As I move around, different stuff is going to get logged out, so we can see exactly what's going in. The foreground layer just not showing up. It's fun. Yeah, so the whole point of what I just did was to enable this layer, and very rudely, this layer just didn't actually show up. Oh, actually, do you know why that layer didn't show up? Because I didn't remake the WOD. Now. Unknown tilemap kind foreground. Yeah. Because we need to think about how... So layers. Can layers have tags? Layers can have UI tags. I really want to be able to say... I guess the way I know is, if it's an int map, it's a collision map, otherwise it's a thing. So I kind of knew this was coming. Decor... Invalid type foreground. So in my compile LDTK, I have this mapping, and this is wrong. Or is it? m.kind. map.kind. Now when we make a map, we say that the kind get name. The kind comes straight from the name. Okay, so if o dot, I want to test when I have a layer, get kind, get kind deco. Oh yeah, hold on, I have a get kind function. Instead of get name, I should be using get kind. Now it'll work. Beautiful. I already solved that problem. Now we can see our foreground layer, and that's cool. It's not in the foreground yet, because we haven't told it to be, but other than that, that's lovely. So now we can have multiple layers being drawn. The problem is, all of our levels, even if a level does not have any data in that layer, right? So, for example, you know, this first area, we want to have this layer present. This level shouldn't have this layer present, because there's no data on it. There's nothing on it. So we can fix that. But to do that, we need to add something to our LDTK. We need a test for a tile layer to say def is empty. right? So if it's a tile layer, we'll say if int grid CSV in self.dict, if len self.dict int grid CSV. So if there's data in this int grid, then return false. If the other thing, what is it? LDTK level, tiles, entity instances. Where's the other layer type? Hold on, where's that defined? I should have put a marker there before I went a scrolling. Level, int grid layer, tile layer, that's it, that is it. Oh, oops, hold on, that's the wrong place. Entity layer, tile layer. Oh no, it isn't tile layer, get tilemap. Grid tiles, that's it. Layer base. Grid tiles and self.dict. If len self.dict grid tiles greater than 0, return false. So if either of those things are present and they have any content in them, then it's not empty, otherwise it is empty. And we can do with that. That'll be good. Now all we need to do before we add a layer to a level is just check that it's not empty. So let's go to compile LDTK. When we iterate over maps, when we build our level, for each layer, if not m dot is empty, just do this check before we add it in. Beautiful. So now I can make WAD, and there's nothing can go wrong. And everything's going to be present, just as we expect. And that's nice. That's really nice. We should test this out. We should log something in here to test this, okay? And let's do exactly that. So in format.c, when we've finished loading, let's log the number of layers in with everything else. This is a big file. This to-do has gone away. We're no longer to-doing it. We to-did it. When we log this out, finish loading level, number of maps equals d header dot tilemap def count. Beautiful. Okay, now we should see it. We should see it. Number of maps 3. Now when we load this other thing, it says number of maps 2. That means that it didn't load the map that had no data in it. That means it's working. And now this last level should also have number of maps 2. And we'll see that when we hit this next loading zone. Number of maps 2. You didn't see it because it loaded so quick, but that's number of maps 2. That means there's only 2 tile maps here. So we can have multiple tile maps that skip ones that don't contribute anything to the final level. That's good. That's really good. The only other thing that we need to consider here probably is in LDTK get in textures. Yeah, so when we go through these layers, if it's a decoration layer and layer dot is empty, we only want a tile set corresponding to a layer with any content in this level to provide its tile set to the asset set associated with this level, because we might have a bunch of different assets, right? We might have different tile sets for different parts of the world, but we don't want to load them all the time. If we don't do this check, then every tile set, because they're all present for every level in LDTK, when we build for the PlayStation 2, if we don't check if that layer is empty, we'll try and load all our tile sets all the time, and then we'll run out of VRAM. The whole point of chunking the world up like this really on the PlayStation 2 comes down to VRAM, right? That's why we do it. That's why we care so much, because we only have 4 megabytes of VRAM to work with total in the whole system, and that includes about 2 megabytes for frame buffers, right? So straight out the gate, we lose about half of VRAM just for our frame buffers and depth buffer, and then we have to squeeze everything else into 2 megabytes. One of the cool things that I've done with this system is, if you have level A and level B, and they use totally different textures, they both occupy the same 2 megabytes of VRAM. So when you draw level A, you upload all of its textures into VRAM and issue a draw, and then while that's drawing, you upload level chunk B's textures, and then you draw against that. And that seems to work pretty well so far. No issues so far. I can also configure it so that they both share about a megabyte each, but my goal is that they can both actually use the same region of VRAM and just always override each other. That would be cool. That would be cool. Excellent. So this is all kind of magic now, right? From LDTK asset paths, we pack things together in a format where the PlayStation 2 knows which assets it needs to load for that level to be present, and also knows how to upload them into VRAM every single frame. The only thing I'm really missing here is a way to say the depth of a layer. And like maybe parallax is a way I could use that. Maybe there's a way I could fake that. Yeah, but that's annoying. Texture streaming was the thing to do for commercial games. There's good bandwidth to work with. Exactly. This is why the PlayStation 2 works at all. It has amazing memory bandwidth. So commercial games, if they want to have any kind of texture detail, you're constantly streaming in and out of memory. You can also make good use of indexed color, right? The paletting system is pretty good. But again, you know, if you want high detail, you're going to be streaming. Mega textures when? So because the PlayStation 2 pipeline is not programmable, there's no shaders on the PlayStation 2, I don't think mega texture works. Clipping a map subset of data. So what is it? Clip map, ITEC 4. How does it, virtual texturing? Texture allocation, use single large texture type terrain, hard drive. I can't remember how this quite works, right? But I don't know if it would even be possible with the PlayStation 2 because there's no shader. You're quite limited. Paging James Lambert. Someone did it on the... Wait, who's the guy who did it on the Nintendo 64? Yeah, James Lambert. That's him. He made it work on a real Nintendo 64. Go check this guy's videos out. They're incredible. I should interview this guy. But yeah, very high detail textures on a real Nintendo 64. Yeah, I'm not surprised everyone here's seen this video already. This is, yeah, insane. Okay. So depth, question mark. We need to work that out. Him and Kaze, yeah. Kaze Emmanuel, another really good channel. Always stay tuned for a Kaze Emmanuel video. I guess we could use the name of the layer for depth. I don't know. I've got some funky ideas about what we could do for depth and foreground, but that's a problem for another day. Cool. So it's kind of annoying, right? That if we want two different tile sets that are used in different parts of the world, those layers always have to be present. That feels a little bit jank, but that's okay. I suppose that's okay. Shade all layers. Focus on the current layer. Nice. Enum tags. That's also kind of fun. One thing I should also do as well, but not right this second, is make this field an enum instead of a string. Because if I make it an enum, then I can define a list of all the possible event types, and I don't have to worry about typos. That would be good. Typos are the enemy of every programmer, you know. Everything works perfectly the first time unless you make a typo. Cool. Okay, that's really good. That's really, really good. We can do decorations. Let's check in with my list. We can do decorations. And I guess like decorations, this gets like a double tick because we did a thing that wasn't really part of this. Better entity system can wait for another day. Let's quickly see if we can do asset reloading because I don't think it's going to be that hard. Famous last words. I think let's have a function. Let's have a really dumb function and let's call it context reload. Right, and we'll just hook this really crudely into main. So let's think, if we want to reload, what does that mean? It means that for every level, I less than level max I plus plus. At the moment we only have 2 levels, but I'm trying to write my code as much as possible to use this level max variable so that if we do end up with a more complicated level streaming, level chunking strategy where we want to have 3 levels, 4 levels, whatever, we can do it. We can just change the number. Okay, so For each level, we just want to say ctx load level, right? I guess we can't do that. There's no. I guess. Well, here's. I guess we want another virtual function. Let's commit what we're doing before we start this next thing. Check for empty. Git add assets, compile, and the other one, which is LDTK.py, commit. What have we got? Oh yeah, remove. Okay, add source. Levels support no longer have hard-coded deco collision maps. Perfect. Excellent commit message. Perfectly summarizes exactly what was in that commit and nothing more. Okay, so let's imagine we have a reload. We actually probably want to say... It probably makes more sense to say context levels I dot reload ctx. Right? That probably makes more sense. And then it can just be up to the level, right? I guess that's pretty good. And then the level can just clear up its own heap, and yeah, I think that's okay. Assume that it's been cleaned up. Okay, so reload, and if that's returned something, then log an error, reload level ID, and then return a bad error code. Something bad happened. Cool. So now we need to add another virtual function to our struct. Another fake, not format, context.h. We're gonna have to go there next though. Level reload function. This takes a struct game ctx, a level context, and not an x and a y. Struct game context, struct level context. Okay, so if we go into format.c, oh yeah, hold on, then the other thing as well. That I always forget to do. When we free a level, we also want to say reload equals 0, right? We want to null all these functions. Reload if ctx levels I reload. Or let's say if it's null, then we just continue, right? We ignore it. Because we don't want to call a null pointer, because that'd be bad. That'd probably blow up. That'd probably blow something up. A server somewhere in the world would catch fire. It's bad programmer mojo. Okay, level reload. So straight off the bat, I should be able to make C source, and it shouldn't yell at me, but it does. No member named reload. What did I do? Context.h. Oh yeah, I defined the function pointer, but I didn't actually add a member corresponding to it. Cool. Control reaches end of non-void function. That's at 176. Return 0, everything okay. Okay, so now we can run, right? And it's always good to check. Just make sure we didn't break anything adding that. And maybe we did. That's either me breaking my code or... Okay, what the hell? Huh? I mean, it looks like I am emitting a halt and catch fire instruction. Unrecognized op. I'm putting some code into the CPU that PCSX2 does not like. So this is usually where it's a good idea to clean and rebuild, because it probably means there's something. And I guess it's because we changed the struct layout, right? Yeah, it's because we changed the struct layout. That makes sense. That kind of makes sense. We changed the struct layout of a struct that has virtual functions in it. I guess it makes sense that blows up. That's a clean rebuild right there. It's because our seek files don't really depend on their headers correctly. Because it's hard, right? It's hard to know what you have to rebuild when a header changes. Sometimes you just have to do a clean rebuild. Okay, so reload is there, and we can call reload. Let's do it here. Let's not do any of this. The trace level debug is not so good. CTX. Okay, we're going to call context reload. And so we can do that. Let's put a log message in when we do it as well. Log debug reload. So when we press select, it says reload. It also prints out the camera. That's nice. That's neat. That's cool. I think that's part of the player. I can't remember. Can't remember where that came from. Cool. So reload. Now we just have to implement it in the actual level. And so what do we need to do? All we need to do is level test, level loaded draw, this function. We just need to call this function again with the current level and the file name associated with this level, right? So we need to know this f name. Now, where does the file name end up? Do we ever put it anywhere? Perhaps not. That could be a problem. I feel like somewhere in the future you're going to have to learn something of ASM for one of your projects while seeing this. It can't hurt to learn a bit of assembly. What I find is when you have a project that requires you to learn assembly, you learn it pretty quickly just on the job. Assembly is really easy to learn, right? It's low barrier to entry because it's just a bunch of instructions. Making sense of what you're looking at, yeah, that's an acquired skill. That's a real art. I'm bad at that. I know exactly the things I'm looking for in assembly, right? So when I jump into assembly, I know how to work out what function it's part of, and I know how to roughly work out what's happening in the function, but I don't know, what line of code it's associated with. Like, once I have to follow a variable through a function and see what register it's in, I get a bit lost, especially once there's optimizations, right? Obviously. What I do know is that I can look at, for example, a store that's causing a seg fault. I can see the register it's using, and I can kind of follow that register back, and I'm like, okay, that was an argument, and that register hasn't been used again, so I know that's actually the second argument to the function. Lua is giving you a run for your head in the last few months. What are you doing in Lua? Lua is an awesome language. I actually have a complete PlayStation 2 Lua scripting environment set up. It's kind of awful to work in, unfortunately. But let's look at these. I need this game called Pew, and it's written entirely in Lua, and it runs on the PlayStation 2 entity. Let's look at like a player entity, right? It's all Lua. Transform, 3D rotation stuff, draw a textured triangle for a sprite, draw two of them because it's a sprite. Yeah, and so this is an entire PlayStation 2 game written in Lua. I actually, when I was writing, or menu system and stuff, yeah. When I was writing my PlayStation 2 graphics driver originally, I prototyped it in Lua. That's why I wrote a Lua environment, because I could iterate very quickly in Lua and work out what the hell I was doing, and then slowly ported stuff over to C. The Lua graphics driver is still in my in the source, but I'm pretty sure it's rapidly falling out of date with the C-based version. I haven't backported changes, but I keep it there for legacy. But yeah, like I made this entire little space shooter game, and for 95% of the development, I was using a Lua-backed 2D renderer. You're making mods for a game called SM64 Co-op DX, a death run game mode. Death runs, character models, export into the game. Had a future go with raid fights. Nice. Death run's taking its time. Yeah, no, that's a cool idea. That's a really cool idea. That kind of scripting environment to retro games is cool. If you follow Ratchet and Clank at all, there's the guy who I've mentioned a few times who's doing the Ratchet and Clank machine learning stuff. He's also built, or he's building, I don't know if he did it originally, but he's building on top of it the Rackman like PlayStation 3 Lua scripting environment where you can modify, game memory and stuff. And you kind of run this program, you write these scripts, and there's online multiplayer. So he's like scripting new game modes into the game, like a race mode into Ratchet and Clank 1, which is amazing. It looks really fun. I don't know any of the speedrun tech to make it worthwhile, but it looks really fun. Or like hide and seek, which is cool, but again, a lot of speedrun tech that I don't know to like flip into weird places and get to spots you're not supposed to be. But yeah, it's all Lua, and it's amazing. It's really, really cool. I'm pretty sure the Kingdom Hearts PC randomizer as well. What is it? KH Speedrun Tools? I'm pretty sure that's a Jank Lua API as well. Lua's great for this kind of thing. Hold on, is this? Yeah, so scripts. Has this been updated recently? I wonder if this works with the Steam release now. Rando sum logic, right? So like all the randomizer logic is based around this idea of, where is it? Where does it actually write? It's really hard to follow. I'm not a huge fan of how this is done, but where is it? It just pokes things into specific addresses in memory. So this is all like reshuffling, but then it actually writes stuff somewhere. Lua can be hard to follow in this way. Oh yeah, read short, right? Add a certain address plus some offset, read a 16-bit word from memory, which is cool. Oh, you implemented the Lua API mod for it. Nice. That's amazing. That's so cool. Yeah, no, I love how easy it is to make Lua APIs for stuff like that. Like, obviously, it's challenging, but Lua is very friendly to it, I guess what I mean. Not to trivialize any work you've done. Nice. Okay, so I got lost then. I got lost in a sidetrack. Reload. We should be able to reload. We should be able to just call this and reload. So let's imagine what this is going to look like. Static, loaded. We prefix these with loaded, even though they're static. Because this is like running on the loaded level, whereas the FMT functions represent the level format, right? So FMT load level means load levels in our actual level format, and then it loads into a loaded struct. Except that loaded struct is local to this file because reasons, because C. Okay, so we have our game context, CTX, we have our level context, level. Now we need this file name, that's right. So we should just be able to call format, load, level. We need to do some cleanup first. And let's borrow directly free level. When we free a level, what do we do? Oh yeah, that's cool. We just free whatever's there. Do we ever reset the, hold on. Are we resetting the heap? I don't think we're resetting the heap when we clear a level. That's a bit of an issue. So we've got to do this, right? Reset the head of the VRAM slice that we use. VRAM slice. We got to reset the allocator as well. Hold on, that's a bit of an issue. How do we reset an allocator? It's a tad restrictive. It's the main Lua function, not extensive kinds. Yeah. It probably just has like, it can be hard to map it directly onto these things. But you can probably build APIs, or like, you know, like some object, some like more extensive kinds, I guess, on top of what I imagine are memory reads and writes. Essentially, that's usually how these retro games do it. You can build good abstractions around that. Okay, so we're missing alloc reset. This is kind of important. And some allocators could choose to ignore it, I guess. But yeah, this is important. Allocator. Level alloc. Yeah. And the state is this. Oh no, wait. We don't even have to do that. This might be wise to do at some point in the future, but we don't even have to do it like that. We can just reset level heap head. Or whatever the original heap was. Context.h, heap head, heap head, yes. Okay, heap head equals 0. Level heap plus level heap head. Yes, okay, heap head equals 0. That's all we gotta do. So in format.c, when we reload level heap head equals 0, reset the heap, and then load the level. Context level, and then we just need the name of the level. So let's go down. I should have put a marker there, that's okay. I put a marker there, perfect. Let's grab this first. The level data, so the loaded level struct. We have a short name. I feel like we also need a file name. Short name. Yeah, that's the short name. That's what we kind of print out. File name len. We can do this too. Define file name len. Let's say it can be 80 characters long. That feels reasonable. File name. So then when we load the level, we just need to copy. When we do all these copies and stuff, string copy, let's say, hold on, level loaded name. That's already there. What am I doing? What am I doing? We're duplicating. We're duplicating. There's a mark there. Loaded, and it's actually part of level. Context.h loaded name. That's right, because we need this to check if the level's already been loaded. So let's go car, because if we start loading, the only thing is, this is a pointer into the levels heap. So if we reset this and start loading stuff into it, there's a chance that partway through this load level, we're going to override that bit of memory. So let's just put it fname equals constr fname. Let's make it 120 characters long on the stack, and then we're going to strcpy. Student copy, we're going to put it into fname destination. The source is level loaded name, and n is 120. I'm pretty sure that's how we do it. Man stern cpy. Destination source n. Destination source n. Same as memcopy. Cool. And then we just say, we just do this. This needs an int, and we just return this. Beautiful. Easy. So easy. Reload everything. Reload the world. Cool. So now we move this to the bottom of the file with everything else. We forward declare it with everything else. And then update is loaded, reload. And then it works. And I guess it looks like it reloaded. So this is running. Let's go into LDTK. And this is a bit too big, right? Let's make it smaller. But let's put two of them there. Hello? Can I copy and paste? Maybe I can't copy and paste. I can't copy and paste, that's okay. Let's make it smaller and replace it with two things. Now I need to... PlayStation 2, side scroller, make WAD. Okay, now I can reload. Cool. I like that. I like that a lot. I like that a lot. Okay, so can we do that on the PlayStation 2? That's the real test. That's like the final boss of this whole stream. So let's go back. Oh, this is still running. Make C source reset PS2. Can this work on a real PlayStation 2? Hold on, I need to press some buttons on my controller. The controller that's plugged into PS2 to make it reset. I don't know why. When you issue a reset to the PlayStation 2, you have to press some buttons before it actually resets. So, here we go. This is exciting. This is really exciting. Okay. Here we go. It's loading. It's loading. It's going to take longer to reload. We're not going to get that instant reload feedback. But that's okay. Now, oh my gosh, this delay on the stream preview is pretty ridiculous. Now that's a loading zone. That's okay. Let's add some stuff to this decoration layer. So let's go back. Let's come back. Let's change this a little. Let's go into the foreground. And let's put some of these weird tiles just like up here. And then let's also move this, because this decoration's a bit weird here. Let's put it over here and let's make it bigger. And then let's put another one here, and then let's put another one here. Okay, we're gonna save it. We're gonna come back here. We're gonna come back here, and we're gonna make WAD. Then we're gonna go back to our PS2, and we're gonna see what happens when we try to reload. I'm going to put it up on this screen, because otherwise I can't really see what I'm doing. Playing off of the stream preview kind of sucks. Oh, we've got the bug. We've got the bug where I'm constantly moving right. That's a bit of a problem. So let's just reload and see what happens. We should be able to see some stuff over on the right of the screen. We should see some stuff up in the top left, I hope. It's reloading. Things are happening. Things are happening. Maybe. 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 Loading. Stuff's loading. It's doing it. Reading tilemap. Oh my gosh, it worked. We can hot reload levels on the PlayStation 2. Amazing. Amazing. I'm going to be back in 1 second, and then we're probably going to raid someone. 1 second. Nice. Nice. Thank you. Thank you all for the celebration. Sorry I had to run off for a second there. Cool. I was should have been a triumphant moment. Instead, it was a quick, a bit of a fizzle. But that's okay. That's okay. Very nice. It's amazing we can hot reload data from a PC onto the PS2, being on commercial hardware. It's incredible, right? It feels broken. I want to do it better. I reckon I could do it better than PS2 Link does. I reckon if I wrote my own like TCP or probably even UDP server, right? Maybe TCP, because I want stuff to arrive in order and like complete. I think I would be able to do it faster if I wrote my own PC client and TCP receiver. But anyway, that's another thing. Once I have threads going, that's something I can consider. But yeah, like being able to do it through this host file system stuff is just kind of magic. And even if there's a bit of a delay, it's really nice. So that was a really good stream. We got some good stuff going. Hot reload wasn't on my list, but I'll take it. I'll always take it. And let's find someone fun to raid. If anyone has recommendations for some cool coding people to raid, I'm always happy to take one. Cozy game dev, tactics game, ASMR programming. Yeah, what have we got? Who are the hot programming streamers out here? Light. So I think art, duo game dev, building. There's lots of interesting looking stuff going on. Doesn't have to be game devy, right? I'm happy to raid someone who's just doing normal old boring coding. I love a good Rust stream. Same category. Game you play as a interesting stuff. Unity. Man, I would like to do something that wasn't just Unity. Random projects in Rust. That seems fun. Rust stream. Let's do it. Let's throw some love over to a little random Rust stream that I haven't heard of before. No mic, no cam. Seems pretty cozy. Seems pretty chill. Let's do it. All right. So thank you everyone for hanging out. Oh, does not accept incoming raids. Never mind. Back to the drawing board. Thanks for the stream. No worries. Yeah, just gotta. It's always so hard. It's like, who do I raid? It's like a lot of pressure, right? Programming a Netflix clone. Cool to see PS2 Dylan. I'm glad people are enjoying it. I always love the feedback. Gotta hear it because it's pretty maddening, right? It's slow, it's painful, so it's good. I need the people to hype me up and keep me excited for it. And once we do 3D, it's gonna be like different. It's gonna be a whole other world. A lot of fun to follow, despite being C. I like to think my C is okay, right? I like to think my C is pretty good, pretty solid. You can write worse C than I do. It's still a bit painful, right? The file loading stuff has definitely taken time, but that's okay. That's okay. This looks interesting. Coding stream. I don't know what this is. I don't know what this is. There's some weird streams out there. I'm taking too long. There's someone's making a multiplayer game, Unity C#. Let's have a look at this. All right. Dench, Yakno, let's throw some love over to them. Thank you everyone for tuning in. This has been a really good stream. This has been good quality. And be sure to show some love to this person, whatever it is that they're doing. And I will be sure to see you all very soon. Bye.